Right. Good afternoon. Uh, Go to the LMS and then download the lecture PowerPoint slides and the data file. So then we are discussing the econometric modeling co-integration and error correction model. Firstly, that let's briefly discuss the what is our econometric model. In the PowerPoint slides, so then go to the PowerPoint, that's slides number 7. Economic model. So then, for example, their relationship between consumption and income. We are writing the economic model like consumption is the function of income. That is the economic model. If we are writing this economic model as an econometric model, add the coefficients, intercept, and the slope. Beta 1 is the intercept, beta 2 is the slope. Right, this is what we call econometric model. The economics, there are different types of economic data. So then time series data and the cross-sectional data, and as well as the panel data. There are variables in the econometric models, independent variables and the dependent variables. You need to identify those independent and dependent variables in your project. Those are, that some key concept you need to know that it is endogenous variable. So it is endogenous variable. It is the variable, if the variable is determined in the model, so then we call these endogenous variables. Exogenous variables are determined outside of the model. Or the lagged dependent variables, or the lagged, we call them lagged endogenous variables. Those are, that predetermined in the model. Although also, that the model is not necessary a model only one equation. If more equations have been specified to determine other endogenous variables, so then we call the system equations, so we call them simultaneous equation model. Static model, a change of the explanatory variable in period t is fully reflected in the dependent variable in the same period. We call this model is static model. Is the dynamic model, we call dynamic model if we include the lag variables to the model, so then we call this model the dynamic model. Right, so then those concepts are important. Also the parameters and the elasticities. If we convert your data to the log, in the log transformation, so then in economically it is, that it measures the elasticities. Right, based on, that this concept, keep in mind this concept. So then it's we are running the OLS regression. When running the OLS regression, there are some 7 assumptions we made. Right, these are the assumptions we made. The model should be linear. It's ordinary least square assumptions. Model should be linear. The error term has a 0 population mean, and the error term is not correlated with the exogeneity, that means independent variables. There is no serial correlation, that means past value do not affect to the model, lag values. The no heteroscedasticity issue, that means equal variance of the model, and the no perfect multicollinearity, that means that is the relationship between independent variables, right? No, that is that multicollinearity. So then we assume that in our model there is no perfect multicollinearity, and then also the error term should be normally distributed, right? Those are the assumptions we made when using OLS, that means regression model. Right, so then now that go to our data file. Now go to the data file. Right, so then there are that's a time series data data file. It's quarterly data from 2000 to 2015, 2000 quarter 1. So then you can see the 2000 Q1 and 2015 Q4 means the quarter 4. Right, those are that exchange rate, export, and the GDP data set. So then assume that we want to test that whether export, are there any relationship between export and economic growth, right? Consider that these three variables are real export, REX, that is real export, right? Consider this variable RER, and there are GDP, real GDP, and real exchange rate, RER, right? Consider all these three variables with the export-led hypothesis, whether it holds. Right, so then what you need to do is, if you want to see the variables, and then highlight, that click the variable RER, and real export and the real GDP. RER, right, that these four variables, REX, and these three variables. Then click right mouse and then open. Right mouse click, and then open. Then as a group. When as a group you can see the variables, list of variables. Right, so then if you use the normal regression, so then assume that it is with a normal regression model you can run. So then it is real export is the dependent variable, other two variables are the independent variable. So then run the OLS model. Right, so then how to run the OLS model? So then go to the quick and estimate equation. Go to the quick, right, estimate equation. Right, go to the quick and estimate equation. Right, then you can see this Right, so then go to the data file in the LMS. Right, there are three variables. So then we want to test whether whether export-led economic growth theory hypothesis hold. Right, go to the LMS and then download the data file. So then in the data file, select, there are three variables. Out of these, select these three variables. RER, it is real exchange rate. REX, it is real export. RGDP, it is real GDP. Right, select all these three variables. Run the normal regression. Apply that for this normal regression. Right, what you need to do is go to the quick, and then there is a button here, estimate equation. Right, go to the select estimate equation. Right, so then here you can see in this box, you can see the dependent variable followed by list of the regressors, including AMA model. Right, this is like this. First, what you need to do is first type your dependent variable first. In our case, dependent variable is real export, RER. It is our dependent variable. Then your in the model, it is that our constant term C. Constant term is C. Right, in this model, C is the constant. ESID is its residual. Right, the next variable, it is real exchange rate, RER, and the next variable, RGDP. Right, those are the variables as mentioned in the you need to type the variables as mentioned in the list. Right, it is that method is least square. Right, in the sample, it is 2000 quarter 1 to 2015 quarter 4, it is the sample. Right, now click OK. Right, this is the OLS, just normal OLS regression model relating to the real export and the GDP. Right, now you can pay your attention for the R squared. Can you see the R squared? So then what the R squared means, it is the explanatory power of the model. It is that it's at the 100%. Right, that means that GDP and the exchange rate 100% explain the our real export. So then that is not realistic. This R square value, it is not the realistic. We know that in practice there are many other factors that affect to the export, but here 100% all these two variables. Right, another reason here, then that are going to the F statistics. Right, when the how to interpret this model, first pay your attention for the R squared, then go to the probability F statistics. The probability F statistics says as a model overall whether it is good or not. Right, so then as I that there are two variables, real export, real GDP and real exchange rate. Combination of both these two variables are exactly good variables to explain our dependent variable. Right, the probability value of the F statistics, it is less than 5%. That means overall the model is good. F statistics shows that overall this model is good. Now pay your attention for the t statistics, probability value of each t statistics. Probability value of each t statistics. Right, so then what can you say about all real exchange rate variable is also significant because the probability value of the real exchange rate is less than 5%. This probability value is less than 5%. Then that means real exchange rate variable is statistically significant to explain the real I got it in other way around. Real export. Your one is same or similar one different? I consider that dependent variable are real. Anyway, right, again go to that quick and estimate equation REX, real export, assumption RER, then RGD. It's something different. RX, real export is the dependent variable. Real, because the previously I took RER is the dependent variable, so then our dependent variable is real export. Then rerun the model. Real export then the R square is 44%. R squared is 44%. That means the explanatory power of the model is 44%. If statistics probability value of the F statistic is less than 5%, that means overall the model is good. The combination of the variable real exchange rate and real GDP as a combination, these two variables are the very good explanatory variables to explain the real export. Then go to the here T statistics and corresponding probability values. T statistics and corresponding probability values. Then you can see that when real exchange rate is not a significant variable because the probability value is greater than 5%. Then the real exchange rate is the insignificant variable. But in the real GDP, it is also a significant variable because the probability value is less than 5%. Then the real GDP is significant variable to explain the real export, right? Those are that basic interpretation of the normal regression line. So then we run this model based on 7 assumptions. Right now we need to check all these 7 assumptions, whether these 7 assumptions are fulfilled or not. If these 7 assumptions fulfill, right, then this model can be used for interpretation. Right, so then here we discussed the autocorrelation, right? The Durbin-Watson statistics measure the autocorrelation, right? So then it is 0.94. The Durbin-Watson statistics we discussed should be approximately 2. Durbin-Watson statistics should be approximately 2, but here less than 2. That means there is a negative autocorrelation issue, right? If it is the value greater than 2, we call positive autocorrelation. If it is less than 2, negative autocorrelation. The Durbin-Watson value should lie 1.5 to 2.5 between that range. So then we can say that there is a no autocorrelation issue. Right, so then now we need to test. This is one of the other heteroscedasticity and whether there is a multicollinearity issue, whether there is a normality issue. Right, now go to the view. Here there is a button here, view. In the view, you can see that residual diagnostics. Right, so then that means what? Why we are that checking the residuals. So then if we there is an autocorrelation problem, if there is a sampling errors, heteroscedasticity shows that the sampling error. If we are doing something any wrong, so then all that go to the error term. So then that's why we assume that errors are normally distributed. Right, so then all these assumptions are made on the errors. Right, so then that's why we go to the weave and residual diagnostics. In the residual diagnostics, there is a correlogram to measure the autocorrelation. Correlogram. We use the correlogram to measure the autocorrelation. No correlogram, so then we use the correlogram for stationarity. So then go to serial correlation first. Serial correlation, that means autocorrelation, right? Autocorrelation. So the number of flags include, because it is a quarterly data, 4 legs, right? Right, so then this is Bruch-Godfrey serial correlation LM test. Here we need to pay our attention for the observed R squared, right? Corresponding probability value of observed R squared. Right, here our hypothesis is there is a correlation, autocorrelation problem or not. Then our null hypothesis is no serial correlation. Our null hypothesis is objective. The null hypothesis is right, there is a no serial correlation. Alternative hypothesis is there is a serial correlation. Null hypothesis is residuals are serially correlated. Alternative hypothesis, null hypothesis, residuals are not serially correlated. Alternative hypothesis, residuals are serially correlated. Right, that is our hypothesis for checking the autocorrelation. Right, so then autocorrelation, that the test, relevant test to test the autocorrelation is Bruch-Godfrey serial correlation LM test. Right, in this test we use observed R squared. Probability value of observed R squared is, this value is less than 5%. Right, if the probability, this is the condition, if the probability value of the observed R squared probability value less than 5%, right, we accept alternative hypothesis. Right, null hypothesis, and first our objective is, normally you know that we are our alternative hypothesis always our objective. Our objective is to test whether there is residuals are serially correlated, right? Our objective goes to the alternative hypothesis, right? Then if the probability value of the observed R square, right, probability value observed R square is less than 5%, right? So then it is less than 5%. You know that what is mean of the 5% means there is a 5% chance of rejecting, right? Then accept the null hypothesis, right? So then we accept our null hypothesis because our probability value is less than 5%. This 0.001, it is less than 5%. So then we accept our alternative hypothesis, that it implies that there is a residuals are serially correlated. That residuals are serially correlated. It implies that residuals are serially correlated. So then same results we can get there have been Watson statistics as said, right? There have been Watson statistics also shows that the model is suffering from the serial correlation. So then it is implied that because these are data series are the time series data, right? So then for the time series data we can't use normal regression analysis because lag values impact for the present value. That means you know that lag of the dependent variable, right? That means in our dependent variable is export, right? So then lag of the dependent variable, that means last year real export impact the this year real export, right? So then this is one assumption is violated, right? There are you know that another major assumptions. Another assumption is heteroscedasticity, right? So then again go to the view, again go to the view, residual diagnostics, go to the heteroscedasticity. So then we assume that our data series have an equal variance, right? That happens. So then when we are studying about you know that real export and the economic growth, considering developed countries and developing countries together, right? So then we know that there is a high variation in developed countries and the developing countries. So then we can't put the we can't analyze considering these two countries together. Then there is an unequal variance of the data. So then we use you know that heteroscedasticity test means we want to check our data series has an equal variance, the residuals. So then there are you know that heteroscedasticity test. There are many tests, right? Mostly widely used test is Brush-Pagan test and also a white test, right? So then let's go to the Brush-Pagan Godfrey test, first one, the white test and everything. So then Arch, all are you know that tests, all these tests are the to test the autocorrelation, heteroscedasticity of the residuals. Then Brosh-Pagan test, right here. Also, our hypothesis, we need to write down the hypothesis, or keep in mind that the hypothesis, our null hypothesis is homoscedasticity, and our alternative hypothesis is heteroscedasticity. That means, in other words, you can write residuals are equal variance. Residuals has no equal variance, right? It is homoscedasticity means equal variance. Heteroscedasticity means unequal variance, right? Same thing. So then, if the probability value is probability values corresponding to the observed R squared, probability value corresponding to the less than 5%, we accept alternative hypothesis. We accept alternative hypothesis. Right, in this case, whether we accept alternative hypothesis, right, probability value corresponding to the observed R squared is 0.8725. It is greater than 5%. Then we reject our alternative hypothesis. Alternative hypothesis means heteroscedasticity. Then in this model is not suffering from heteroscedasticity. So then that assumption is fulfilled. Right? There are 7 assumptions in the model. Right, basically, so then heteroscedasticity, autocorrelation, and the normality, and the stationarity correlogram. So then those are the tests we are doing. Right, so then this model is so far this model is suffering from a serial correlation problem, autocorrelation problem, but not the heteroscedasticity problem. Now go to the again view residual diagnostics. And then residuals are normally distributed or not. Normality test, histogram, normality test. Right, normality test. Right here, normality test is there is a Jack-Bera test is used to measure the normality. Right, these are residuals are normally distributed. Write down the hypothesis here. Residuals are normally distributed. Right, our null hypothesis is residuals are normally distributed. Our null hypothesis is are normally distributed. Alternative hypothesis is residuals are not normally distributed. That is, we have hypothesis. Null hypothesis is residuals are normally distributed. Alternative hypothesis, residuals are not normally distributed, right? So then here, if the probability value is less than 5%, the probability value is less than 5%, we in this case, what happens, probability value is less than 5%, so then we can confirm that residuals are not normally distributed, right? So then here, this model is suffer from autocorrelation. That means we ignore the variables last year or the last quarter real export, right? So then if we do not consider that variable, it goes to the error term. So then that is the error we are doing, right? So then it disturbs to the error term, right? Then another, again, that go to the wave. Then the model is suffering from autocorrelation. Then the model is suffering from the normality issue. Other one is, that correlogram, the data series are stationary or not. That is correlogram table here. Correlogram Q statistics. Lags is okay. It's default one, so then it's select the default is okay. So then you can see that here autocorrelation and the partial autocorrelation, right? So then it is our in the autocorrelation. What is our hypothesis? Null hypothesis is residuals are not serially correlated. Our alternative hypothesis is residuals are serially correlated. The probability value is less than 5%. Then we can confirm that the model is suffer from serially correlated. Then this is a serious issue. Serious issue in this model is autocorrelation. The residuals are not serially correlated. That means for the macroeconomic variables, past value impact for the present values. That means the dependent variable, our dependent variable is real export. The last quarter real export impact for the present quarter export. So then we ignore that variable, right? In our model, we ignore that. We do not consider that variable, right? That is autocorrelation. Then the major issue in this model is autocorrelation. So then that's why we can't run this model by using normal regression analysis, right? That's what we talk about, the model assumptions. Right, so then now we know that there is a separate analysis we need to do for analyzing the time series data. Right, so in the that PowerPoint slides, it mentioned the serial correlation. So there is a serial correlation. What is the serial correlation means? Error terms across observations are correlated with each other. Right, so then error 1 is correlated with the error 2, etc. Right, this is most important in time series. If the errors are serially correlated, an increase in the error term in one time period, it impacts the error term in the next period. Homoscedasticity, it means errors has a constant variance. So then normally in the heteroscedasticity issue is not in time series data, but that problem arises if we consider that developed countries, and when the study developed and developing countries, we are considering both countries together rather than analyzing separately. So then this issue comes. So then other one is that perfect multicollinearity, right? In the we can check the multicollinearity as well. Here there is no separate statistics for calculating the for checking the multicollinearity, but in the SPSS there is a facility, so then we call it VIF factor, tolerance factor, right? But here we can use quick group statistics, right? Go to the quick and group statistics, right? Then check the correlation, right? Correlation, right? By using correlation we can check the multicollinearity, right? Those are the variables: our GDP, our real export, and real exchange rate, right? So then our dependent variable should come first. Real export, real GDP, and real exchange rate. So then better to that give dependent variable first. Right, then click OK. This is our correlation table. In the correlation table, pay your attention for the correlation values. So then we assume that there is a relationship between real export and real GDP is a positive relationship. It is 0.65. Real exchange rate and real GDP, this value is 0.65. That means a positive correlation between real export and the real GDP. Then higher the GDP, higher the export, like that. But the real export and the real exchange rate also, that positive relationship, right? Higher the exchange rate, higher the export, like that. But it is weak relationship, 0.04. It is a weak relationship. But here, real GDP and real export, that is okay. There is no serial correlation issue in this model. Then the real exchange rate and the real GDP, the relationship is 0.07. So then if in this model there is no highly correlated variables among independent variables, right? If there is a interrelationship among the independent variables, but in this case independent variables are the real GDP and real exchange rate. Now real GDP and real exchange rate, there is no highly correlated relationship between these two variables. If it is, so then we can confirm that the model is suffer from multicollinearity. Right, this is multicollinearity. right. So then now this is that the way we are interpreting our regression results. Heterozygoticity, and we need to check autocorrelation, right? The testing the autocorrelation Godfrey LM test, and then also we use the Durbin-Watson test. That value should be approximately 2. Durbin-Watson close to 2 indicate that first autocorrelation coefficient. Right, so then what to do when you find autocorrelation? Right, so then in many cases finding an autocorrelation is an indication that in this model is suffer from autocorrelation. So then if the model is suffering from autocorrelation, what to do? So then it is an indication that the model is misspecified. So then we are not that clear about the theory or the existing relationship between the variables what we are considering. Right, so then it is it may be that dynamic specification, so the omitted variable, or the functional form misspecification. For the remedy for that, we need to add the lag value of the dependent variable to the model as a solution. So then if the model suffer from autocorrelation, one remedy is, in our case, lag of the real export. Right, here yt is beta 1 beta 2 x1 xt, and then this is the beta 3 yt minus 1 is that lag of the dependent variable. Assume that yt is our real export, then we include the lag of the real export, that is last quarter real export. So then that is the remedy for the autocorrelation. Right, if you consider that this model, and then if we run this model, right, so then don't use the Durbin-Watson test to check the autocorrelation. Right, so then the correct test is Godfrey test, LM test. Right, if you run this model, the lag values, if your lag values are included in the independent variables, right, like in this model, there is a lag value we include as an independent variable. Right, the lag value we include as an independent variable. If so, don't that if you run this model, right, regress this model, and then check in the model specification, so then don't use the Durbin-Watson test. Right, it is not valid for that. If the lag value are included as an independent variable, correct test is Godfrey Lagrangian multiplier LM test. Right, so then you can rerun the model including this, and then if you want, and then you can run this model. Right, again go to the quick group estimate equation. Right, so then you can run the model again including R export, real export, R and REX minus 1. Put like this, it is minus 1 means lag. that means in our data quarter data, so then -1 means last quarter. If it is yearly data, -1 means last year. Right, within bracket -1. R -1, lag of real exchange, real export. Right. Right. Then our model suffer from autocorrelation. One remedy is include the lag of the dependent variable as an independent variable to the model. Right. So then we add another one. So then again no need to generate again variable. If we put RER within bracket -1 means lag of real export. Okay. If it is that RER within bracket -2 means 2 lags. Right. If RER -3 means it is third legs. That means 2 quarters back and 3 quarters back, or the 1 year back, like that. So then we can run the model. Right, if we add the real lag value of the real export to the model, now you can change see the what is that happening to the model. R squared it increase 40% to the now 60%. F statistic it is also okay. It is less than 5%. All variables are significant now. Real export, lag of real export is a significant variable. Real exchange rate is also the significant variable. Our GDP is also the real GDP also the significant variable that impact to the real export. Right, now you can see that Durbin-Watson, don't that pay you attention. If you add lag values to the lag value as an independent variable, don't that look at the Durbin-Watson test to check the autocorrelation. Now you can check the autocorrelation by using the serial correlation LM test. Right, see that. Then no serial correlation. The probability value is less than 5%. If it is less than 5%, the model is residuals are serially correlated, but here residuals are greater than 5%. Then no serially correlated. Right, then check the normality, residuals, and then check the normality. Its Jack-Berra test shows that there is a normality issue. Residuals are not normally distributed. Right, that assumption is violated. But the autocorrelation problem gone. But also that pay your attention. So then whether that sign of the when the higher the GDP, higher the export, that sign is okay. Then the higher the real exchange rate, higher the exports. So theoretically, is it true? It's okay. That maybe that if the sign of the coefficients may change. Right, it is also not good thing. Residual, so then heteroscedasticity. Brush. It is an heteroscedasticity issue. Observed R squared, no heteroscedasticity. Right, the model is not suffering from heteroscedasticity issue except the normality issue, right? That means residuals are not normally distributed. One assumption is again violated. Right. Right. This is that basic regression. How to that apply the basic regression for the time series data. How to that analyze the how to apply the basic normal regression analysis, that means OLS, to the time series data. How to check the model efficiency. So then those are that model efficiency. If those assumptions are fulfilled, so then this model can be used for interpretation. So then the normal regression analysis, so then we can use for the cross-sectional data. But the time series data, so then this especially that autocorrelation problem issue, it arises. For the cross-sectional data, so then this is normal regression analysis can be used. Right, so then this is our data, the time series data. In the time series data are we call non-stationary. Right, non-stationary means it is trended. So then if we graph the real export data, if we graph the real GDP data, if we graph the real exchange rate data, so then those are non-stationary. That means they are trended. So, data can be regarded as the potentially the major issue for empirical econometrics. Right? It is well known that trends, we call trends, or that either stochastic or the deterministic trend. Right? It impact to the serious issue when we are using regression analysis. We call spurious regressions. That means nonsense regression results. So then we gain results, but these results are not realistic. So then uninterpretable student's t-value. Right? Sometimes that R squared may be very high. All the variables are significant. Maybe that signs are not expected sign. So then also that goodness of fit, the explanatory power is very high, too high. Goodness of fit means that explanatory power, that means R squared, right? It measures which are too high. So then sometimes it may be that 90%, 95%. So then it is also not the good sign, right? R square is 99%, 95%, it is not a good sign. The reason is the time series data, because the trending, non-stationary data. So then make regression results rather difficult to evaluate. So then because of this reason, regression results is not realistic. So then most macroeconomic time series are subject to some type of trend. So then as a remedy for that, so then we use the stationary check, co-integration, and the vector error correction model. Right, so then in this data set, check right, so then graph, first see the graph, so then go to the quick and graph, quick and graph. Right, if you analyze the time series data or whatever the data. So then first see the descriptive statistics, descriptive analysis by using mean mode or that by using graph. The behavior of the data, right, is graph. So then what are the variables we need to graph? Real RE and RGDP and RER. Right, those are the three variables we consider. Right, type all these three variables. Then click OK. Right, when click OK, so then there are different types of graph. It's a bar graph. It's a line and symbol because it is time series data. The relevant graph type is line. Right, one axis is the time, other axis is the real exchange rate or the real GDP or whatever. Right, here multiple series, the single graph. If you select the single graph, so then all the graph in a one graph, or line one. Right, if you want to the multiple graph, separate graph for each variable, so then click multiple graph. Right, then click OK. Right, then you can see the graph. Right, you can see that trend. So then the data are, it's not stationary, non-stationary. That means there is a trend in all these three, except that this real exchange rate, other two variables, that it is trending, non-stationary. Right, this non-stationary data series, the normal regression analysis cannot be used for the non-stationary data. Right, so when we are running time series data, first thing is you need to check whether series are stationary or not, trending or not. Right, so then if they are stationary, right, stationary, that means no trend, so then these variables are co-integrated. Right, if these variables are co-integrated, that means errors also, important thing is the error. So then what we are doing when we are doing research, so then we are doing an error. So then means specification of the variable, omitting variable, so then all that go to the error. Right, so then that error also should be stationary. Right, it is that so then we need to check then the stationary of the variable, and when the variables are stationary, so then it is said that there is a co-integration of these two variables. That means co-integration means there is a long run equilibrium of the variables. Right, so then first thing is what we need to do is check the stationary, whether series are, this is a graphically, so then that's the way we are checking the series are trending or non-trending. Right, so then there is a specific test to test. Right, so then the third graph, so then we can't say that it is trending or non-trending. We can't say, just see in the graph. Right, there is a test. We call this test is unit root test. Right, so then first we need to test, check the unit root test of each variables to find the order of integration. Right, it is to find the order of integration. If the all variables should be integrated in the same order. Same order means that first difference variable is, it is assumed that it is said that mostly macroeconomic variable first levels, we call these series are levels data. data as it is, right? These level data are non-stationary, but the first difference of the series are stationary. Most of the time, the first difference of the series are stationary, right? There is a no trend. So then all these three variables should be integrated in the same model. Assume that in our real exchange rate should be first difference is stationary. Also the real GDP should be the first difference stationary. Also that real exchange rate also should be stationary at the first difference. Right? If the first difference are not stationary, then go for the second difference. Right? Like that. Right. Then that after checking that, then the next step is to estimate the model, our co-integration equation model, that is long run model of the variables what we consider. Right. For the co-integration test, there is a test called what is Johansson co-integration test. Right. So then here, when I'm writing it here, right here, if the data test unit truth, right? Why we are using unit truth? Right, unit truth test. Unit truth test is used to test the stationarity. Right. Stationarity means trended, whether data are trended. Right. Then the co-integration test. Johansson co-integration test. Johansson co-integration test is used to test the co-integration, or to test the long run equilibrium. To test the long run equilibrium, we use Johansson co-integration test. Right, so then now it is clear for you. So then why we are using the time series? When we are using the time series data are trended. Right, so then in our example also we can see that is time series data are trended. So then we can't use the normal regression analysis. So then it's a classical regression analysis, not the normal, it's a classical regression analysis to analyze the data. So then if we use classical linear regression analysis like we did, but our results, regression results, are not realistic. So then our t-values of that means significance of the each coefficients are not realistic. Also that it shows the high explanatory power. So then those results mislead the reality. So then the most macroeconomic time series, we know that they are that with the time there is a we can see there is a series are trended. That means non-stationary. So then for that purpose we use unit root and the co-integration test as a remedy for the time series data. Right, so then now as our data set, go to our data set again. Right, so then assume that here we have a model. Here we want to test that export-led growth hypothesis hold. Right. So then here real export, real GDP, and the real exchange rate, these three variables. Right, so then test the unit root. So then graphically, so then we first that you need to first thing is graphically illustrate, right, graph and see whether there is a trended series are trended or not, right. The next, then go for the formal test, right. In our variable again, that go to the graph right. You can see that if we draw graph everything in the single graph, so then what happened, you can see, so then you can't, that is not a clear picture. Right, these are the series. You can that cut and the copy in your in your text to the word file. So there is a real exchange rate, and then this is real export data is a trending, and the real exchange rate for up to that 2013. So then it is okay. So then after that 2013 and again 2015, you can see that big fluctuation. Or the real GDP is also the retrending. So then what happened, the 2013, something happened 2013, interpret the real exchange rate, and then real export as but with when data show some. So the real exchange rate is very high. Maybe that 2013. Again 15 again that down. Right. Need to think about that what is the rationale behind that. This is Sri Lanka, so then data the Sri Lankan data is. We got this data from the customs. Right, now we check first if your data series first check the whether series are trended or not by using a graph, right? That is the first step, right? So then if you want, and then this cut and then paste to the Word document. So then do the same for your data analysis, right? Otherwise you will forget the steps, right? So then it says, that just, that right click, clip, copy to clipboard, then copy and then paste to the Word. Right? Do it, that otherwise if you're facing an issue. Right, then you can write some description about the behavior of the each variable separate. Right, when in your writing you need to write a brief description of each graph separately. Right, in the co-integration equation there are some that equations. So then here I can't write it, or more facility to write equations. Right, I'll let you know later. So then what is how to write the equation. Right, when writing a report, these equations are mandatory. Right, in the methodology section. Right, so then you need to get an understanding for that as well. Otherwise, that just that output is not enough, especially for this PhD level. Yes, I'll let you know these equations later. But here that in this system, no facility to write the equation. I can write in a board, but the students cannot see. Right, so then now go to the now go to the go to the quick, and then series statistics series. Right, data series, each series now we are checking, right, they are on the correct stationary process. All series are stationary or not, right, before using the regression model. Then there is a test, unit root test. Right, so then click unit root test. So then give the series name, all series separately one by one. Right, first real export, only that each series separately. Right, only a real export, then okay. Right, so then in the here unit root test, so then there are different test types. You can see, right, different test type. First one is augmented Dickey-Fuller test. Right, it is also the Philip-Perron test also. These two tests are the mostly widely used test. Philip-Perron test and the augmented Dickey-Fuller test. Right, first that go for the augmented all that most of the research report use these two tests, right, together in the report to test the unit root or the stationarity. Then first that augmented Dickey-Fuller. So then there are tests for unit roots. There are three types of test. Right, levels means data as shown in the series. Right, data as shown in the series, that's what we call levels. First difference means difference between this year and the last year, that difference area. The second difference means again that this second difference area, right? So then test equations, right? There are three types of trend equations. There is intercept. We assume there are three models. So then in the equations we can write all these three, right? In the intercept, so then we assume that they only intercept, no trend. The second one, we assume that for the series has a trend and as well as the intercept. In the third one, we assume no trend, no intercept. Right? Right. So then we include intercept and the trend. Trend and intercept if the data is trended. Our export, real export one is trended, first variable. So then it is, so then we can select trend. We assume that there is a trend and intercept. Right, so then normally if the level data, so then is a levels data. The data as shown in the series, it is level data. So normally the level data, we assume that there is a trend and intercept, right? So then that's why we are checking the stationarity. We know that's a series are trended, so then we assume there is a intercept and there is a trend. Then the select it. But if we consider the first difference, so then there is a no trend. If that first difference means value becomes smaller and smaller, then no trend there. Right? That's why we consider that difference, right? Difference between the two consecutive years. So then the value becomes too small. Then that trend is move away. If we consider that first difference, if we select here first difference, here we select intercept, right? Only intercept, right? Also then if we select levels, we assume there is a trend and there is an intercept. Here we are testing our levels data, so then it's a trend and intercept. So then automatic selection, lag length, and then here maximum lags. Here maximum lag is 4 is enough. Then the 4 lags, 4 quarters is enough. Automatic selection, right? It is default one. Keep default one. Short source information criteria. Right, that's it. So then now click OK. Right, this is the augmented diffuser test results. Right, so then these test results are very important, and then if you want, and then here that copy and paste to the Word document. That unit code. That it is augmented diffuser test statistics. Right. Then now write down the null hypothesis. Here write down the null hypothesis is more clear. So the null hypothesis is here. Write down the null hypothesis. The variable or the series is stationary. Alternative hypothesis. Variable is not stationary. That is mandatory. You need to keep right here. So then in here also null hypothesis mentioned, right? Null hypothesis REX in our real export has a unit root. Unit root means that variable stationary. So then that means variable has no unit root, right? That is another way to write the hypothesis, right? If the variable is stationary or the variable is not stationary, or that other way around. So then real export has a unit root and then not unit root. Then you can see that the probability value is less than 5%. Then we accept alternative hypothesis. That means variable is not stationary. That means trending, right? Trending, right? So then now what we need to do again, go to the same. Right here, go to the view. So then go to the view, view and the unit root test. A series second. So then go to the unit root test. Levels select kare. Now go to the first difference. The first difference select karo. So then you need to select karane. So then intercept. मतलब trend එක දැන් අපි අයින් වෙනවානේ. එතකොට අපි දැන් assume කරනවා first difference එකේ trend එකක් නැහැ කියලා. අපි assume කරලා ගන්න. series levels වල අපි දන්නවා in the graph trend එකකුත් තියෙනවා. so then assume කරන intercept එකකුත් ඇති කියලා. එතකොට අපි difference කළොත් ගොඩක් වෙලාවට අර trend එක නැති වෙනවා. difference කරන one reason for differencing is remove the trend එක. hence අපි දැන් trend එකක් නැහැ, but there is an intercept එකක් ඇති කියලා හිතන්න. It's non-stationary. It's non-stationary වෙනවා එක. But assume that ඒකට wave එකක් තියෙනවා කියලා. So then assume that is trend again. දෙවෙනි සැරේට trend එකක් තියෙනවා කියලා. Is all same. Second difference එක let's see. It's non-stationary. It is also stationary, non-station. Third difference. So then, anyway, so then consider that is the same, the unit root and then intercept. is constant. Yeah. Then go to the again other two variables. So then go to the quick new variable so then go to the quick and series statistics and the unit root RGDP. Go to the plus levels and trend and intercept. Length. 10 dila bagam leg length. Leg length එක 10 යනවා අපිට. අපිට leg length එක අපි හතරම දීලා බලමු. एक unit root here. ඒකේ levels වල stationary වෙනවානේ levels වල stationary station. Right there, check that other variable as a series unit root test REX levels. The unit root test put that maximum legs for everyone. Trend and intercept. And check the plus difference as an intercept. Get the variables, that first and second difference. And only the first difference. maybe I'm not sure. So then maybe so then I write hypothesis is wrong way. So then it's a variable is non-stationary. It is stationary. I want to check it. This variable is non-stationary. So then it is our objective is to check the stationarity. So the normally alternative hypotheses are our objective, because our objective is not to check the autocorrelation. So then it is alternative hypothesis is autocorrelation. So then it's a no autocorrelation goes to the top. So then it's a non-stationary. So then variable is stationary. I don't know this data set. So then here, except that real export data, other data are stationary. Anyway, so then consider that second difference for all the series. The real export second difference, it is stationary. So then if you change it, it is variable alternative hypothesis variable is stationary. Maybe hypothesis is disabled to check it. If so, that second difference variable is stationary in the real export. RGDP also, second one stationary. Real export, first one both stationary, second one also stationary. For applying the co-integration, all series should be stationary in the same order. Samahare levels or samahare first difference or samahare second difference, so then we can't choose. That keep it, remember. So then if all the series should be integrated in the same order, otherwise we can't use co-integration analysis. But there is no remedy for that as well. If assume that there is a real export is co-integrated in the second order, but others variables in the first order. But there is a shortcoming of this model, of this vector correction model. Right. Assume that in the second difference. Sorry, first difference is pointing in the all are stationary in the first difference. Assume that. Right. Then we move to the if all the series are integrated in the same order. Assume that all are integrated in the first difference. Right, then we can move to the next step. Otherwise can't go. Right, otherwise can't go. So then we move to the next step. That step is co-integration. Right. Right, group statistics, Johansson co-integration test. Right, Johansson co-integration test. Go to the Johansson co-integration test. Right, then you need to give the name of the all variables, all series. Then dependent variable first, R export, then RER. Right, 3 variables, because if we have 6 variables and then list the all 6 variables. Right, here there is co-integration test specifications. There are 6 specifications. Right, among these specifications, in this option, so then we use deterministic trend. So then the third one, It is default one, so then we are using this. Intercept within bracket no trend in co-integration equation and test VA. That is the option we select. So then number of lags you need to include. So then here we quarterly data. So then is four lags or 2 lags, 8 months. So then is a four assume that is 2 lags in a. Right, so then no exogenous variable, so then assume that all are endogenous. Right, then click OK. Because in this model we assume that it is a simultaneous equation model. So then real GDP depends on real export depends on real GDP and real exchange rate. Likewise, we assume that real GDP also other way around. Real GDP also the function of real export and real exchange rate. Real exchange rate is also the dependent variable. All variables act as a dependent variables. It's a simultaneous equation model. Right, then click OK. So then now you can see that number of co-integration equations. So then how many co-integration equation it include? But here there are two tests to check the how many co-integration equations. So then one is eigenvalue test, other one is trace statistics. So then here trace test shows that no co-integration equation. No co-integration. Here it says that no co-integration. Right. Here maximum eigenvalue test. Also, that says that no co-integration. Both tests. A trace test shows that no co-integration equation. The maximum eigenvalue test also shows that no co-integration. Right, so then here I mentioned that is a one co-integration equation. Right, if there is a two co-integration equation, that is the equation. Right, so then if we assume that if we increase the leg length, the same. There is a no co-integration equation. Right, then copy and then we test. Also, then I forgot, that say the Philip parent test also, that you can do the same for check in the unit root. Yeah, same test. Both tests should be done. Here, so then now in this model says that there is a all series assume that all series are integrated in the same order. So then we are checking whether there is a long run relationship among the variables, right? So then here says that no co-integration means no long run relationship, right? If there is a no long run relationship, uh, here that is important. Here no long run relationship. I'm writing it here. It is better, right? If there is a no long run relationship, right? There is no long run relation based on the that test and the maximum eigenvalue test shows that there is no co-integration. That means no co-integration means no long run relationship, right? So then use vector error correction model. Have you heard that vector error correction model? We can't use the vector error correction model. Then we can use vector auto regression model. There are two types of model. If the variables are of the series are co-integrated, that means there is a long run relationship, then we use vector error correction model, right? If in our data, this data set, so then there is a no co-integration relationship, that means there is a no long run relationship, then we can't use vector error correction. Then there is another model use vector auto regression. We call it VAR. 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 We call it VAR. Other one, vector error correction model. VEC. Vector error correction VEC. Vector error correction model VECA. Right? Right, there are two types of models. So then we can't that just say that we are using VAR. There is a reason of using VAR model, right? Both are VAR, but here there is a two types of VAR, restricted VAR and unrestricted VAR. But here in I'll show you in this model. Here estimate VAR. Here estimate VAR. Right. So then now you know that our series are stationary in the stress difference, right? That means series are integrated in the same order. That means stress difference all are that's stationary. When after checking that, if the series are integrated in the same order, then our next step is to check whether there is a long run relationship. So then that means to check the co-integration. If there is a co-integration, so then we can confirm that co-integration. So then that model we use is vector VEC. If it is not co-integration, so then we use VAR. So then after that, we need to estimate our model. Here estimate VAR, not that estimate equation. So then here estimate VAR, right? In the VAR, so then you can VAR type. Two types of VAR. Here another Bayesian VAR itself. Here unrestricted VAR and the vector array correction. Right here here we call vector array correction or restricted VAR. Right here restricted var, so then it's unrestricted var. This is long-term relationship. This is not. This is just simultaneous equation one. All the variables act as a dependent variable in the unrestricted var. In the unrestricted var, there are that is a normally that we assume at the beginning the real export depends on other two variables. In the unrestricted var model, real export acts as a dependent variable, real GDP acts as a dependent variable, real exchange rate act as a dependent variable. Then there is a three model as a that is a simultaneous equation. Right. Then next week let's discuss that it's an unrestricted and restricted var model. So then you need to give all the variables. All are that now you can see that all are endogenous. All variables are endogenous. All are act as exogenous because that exogenous variables and the endogenous variables. But our dependent variable, it is an endogenous. Others are exogenous variable. But here in this case, all act as the dependent variable, endogenous variable. Then all the three variables we mentioned here: real GDP, real export, and real exchange rate. All act as endogenous. But at the beginning, we assume that our exogenous real export is the exogenous variable. Now, take දැන් එහෙම වෙන්නේ නැහැ. මොකද අපිට මේ තියෙන ටෙස්ට් එකෙන් it shows all variables depends to each other. එහෙම වෙන්න පුළුවන්. So then export real GDP is a function of export. ඒ වගේම export වැඩි වෙන්න පුළුවන් GDP එක වැඩි වෙනකොට. නේද? එතකොට අනිත් පැත්තට වෙන්නත් පුළුවන්. රටේ GDP එක වැඩි වුණොත් ඒක export වැඩි වෙන්න හේතුව. දෙපැත්තට. ඊට මෙතෙන්ට ඒ all variable ටික දෙනවා. Then අපි දැන් දුන්නත් for example it's a vector correction නෙමෙයි unrestricted var. So then RER GDP and RER තුනම දෙන්නවා. එතකොට වෙන ඉක්වේෂන් එකක් වෙනවා. මේක තමයි dependent variable එක export එක dependent variable එක. R GDP එක dependent variable එකක් වෙලා තව model එකක් එනවා. Right? R exchange rate dependent variable එකක් වෙලා තව model එකක් එනවා. ඒතර model තුනක් හැදෙනවා. right එතකොට අපි lag දෙකක් ගත්තනේ. ඒතර lag අපේ කලින් හතරක් ගත්තා නම් එහෙම මෙතන -1 -2 -3 -4 කියලා variable හතරක් වැටෙනවා. මෙතන අපි ගත්තේ lag දෙකයි. නමුත් අපි maximum lag එක select කරන්න මේ criteria එකක් තියෙනවා මේක. ඒක කොහෙන් මේ lag length criteria එතනම click කරන්න. එතනම view යන්න. lag structure ඊට පස්සේ lag length criteria කියලා එකක් තියෙනවා. ඒකට ගිහිල්ලා අපි දැනට දෙමුකෝ හතරක් විතර. අපි හතරක් දෙන්නේ මොකද අපි quarter data නිසා quarter හතරක් ඈතට. ඒතර මේකෙන් පෙන්නනවා lag length criteria එකෙන්. මේවා තමයි lag length criterias. So then you can see this. Making a highlight කරලා you can see clearly to make it famous. So then you can see there are that these are the මේවා තමයි lag length criteria. මේ තියෙන පෙන්නලා so then එකක් LR test එක අනිත් එක EPE final prediction error test එක so they normally use the IK information criteria එක තමයි so they normally use Schwarz information criteria එකත් තෝරගන්නවා අපි සම්මන්නේ and mostly widely used test එක තමයි මේ දෙක නමුත් so then ඕන එකක් use කරන්න පුළුවන් so majority test බලන්න majority of test එතන මේ FPE test එකෙන් කියලා තියෙන්නේ second leg එක තමයි හොඳයි කියලා. ඒ ස්ථා වෙන්න තියෙන එකයි. එතකොට ඒ අකයිගේ information criteria කියනත් පෙන්නනවා දෙක හොඳයි කියලා. නමුත් Schwarz criteria එකෙන් පෙන්නන්නේ එකයි. පළවෙනි leg එක හොඳ කියලා. but HQ criteria එකෙන් තුන. يعني second leg එක හොඳා කියලා. ඒ නිසා අපේ majority of test leg දෙක හොඳයි කියලා තියෙන නිසා so then we can select the second leg. මේක මත depend වෙනවා නම් මේක ගැන විතරක් කියන්න. Based on the Schwarz information criteria they select that first leg is the okay. Now majority of the test shows that the test තුනකින්ම තියෙනවා නේද මේ test එක so then LR test එක කියන්නේ fourth leg එක okay. LR test එක fourth leg is okay. එනිසා අපිට majority of the test shows that second leg is okay so then අපිට එනිසා second leg එක ගන්න පුළුවන් ඒතර මේකෙන් confirm කරනවා why we are selecting second leg. මේ තමයි ඊතර අපේ වා මොඩල් එක. But අපිට so then before checking the unit root of the series බලන්න ඒ series ඔක්කොම සමහර ඒවා මේ series එකෙත් මට අගුණ check it සමහර ඒවා dollars වලින් තියෙන්න පුළුවන් සමහර ඒවා rupees වලින් තියෙන්න පුළුවන් සමහර ඒවා percentage එකක් විදිහට තියෙන්න පුළුවන් නමුත් අපි එකම series එකකට convert කරගන්න ඕනේ before checking the unit root මේක එහෙමද කියලා දන්නේ නැහැ check කරන්න તમારે વાર રૂપીસ ඉස්සෙල්ලා සීරීස් ටික එකම જાතියකින් හදාගෙන ඉන්නවා. දැන් ඩොලර්ස් වලින් තිබිලා සමහර ඒවා සමහරව රුපීස් වලින් තිබිලා සමහරව පර්සන්ටේජ් එකක් විදිහට දෙන්නත් පුළුවන්. එතකොට අපිට unit root test කරන්න බෑ එහෙමනම් ඔක්කොම percentage වලට හදාගන්න. එහෙම නැත්නම් ඔක්කොම අපි කියමු රුපී වැලි වලින් තිබ්බනම් log වලට confirm කරනවා. transform කරන්න. ඒ වගේ එක series එකකට හදාගන්න ඕනේ. දැන් මේකෙත් මට check කරන්න බැරි වුණා all series in the same mode එකේ තියෙන්නේ කියලා. ඒ කියන්නේ same mode නෙවෙයි same මේ මොනවද measure එකේ තියෙන්නේ කියලා. ඊමේල් කරගත්තා නම් යන්නේ. අපි ඊළඟ සැරේ වා මොඩල් එක දැන් ඔයාගේ data set එක අනුව තමයි තීරණය වෙන්නේ. වා මොඩල් එක ඇනලයිස් කරලා සහ වෙක්ටර් කරෙක්ෂන් මොඩල් එක දෙකම ඇනලයිස් කරන හැටි ඊළඟ සති දෙකේ කරන්න වෙච්චද. ඔය වා මොඩල් එක ඇනලයිස් කරනකොට ඔයගොල්ලන්ට මට රීඩ් කරනකොට අහුවෙලත් ඇති impulse response function and then variance decomposition ඒ කියන්නේ වලින් තමයි අපි මේක ඇනලයිස් කරන්නේ. ඒ කියන්නේ when something happen, assume that real export අපිටම political change එකක් ඇති වුණා. ඒ political change එකේ impact එක or the monetary shock එකක් වගේ එකක්. ඒවැ impact එක කොහොමද real export වලට real GDP එකට effect වෙන්නේ කියන එක තමයි මේකෙන් අපි analyze කරලා යන්නේ. මේ වා model එකේ. දැන් මෙතනත් පේනවා ඇති මේ impulse කියලා එකක් තියෙනවානේ. මෙතන තියෙන impulse මේ impulse කියලා කියන්නේ මේ variables ටික මේ impulse කියලා කියන්නේ ඇත්තටම shock එකක්. monetary shock එකක් හරි physical shock එකක් හරි. right? ඒ shock එකක impact එකක් කොහොමද බලපාන්නේ කියලා තමයි මේකෙන් කියන්නේ. අපිට මේ වගේ අපිට graph වල අඳින්න පුළුවන්. දැන් මේ තියෙන්නේ ඒ graph එකේ පෙන්නන්නේ ඒ shock වල impact එක. දැන් මෙතන graph එකක් මට create කරගන්න. මේ පේන්නේ චූටියට වැටෙන මත graph ගොඩක් නේ. දැන් මේ දෙන real export එකටම effect වෙන විදිහ. any shock to the export market එකට ඇති වුණොත් ඒක export වලට කොහොමද effect වෙන්නේ? ඒ කියන්නේ මුලදී down වෙනවා. පස්සේ decrease වෙනවා කියලා dramatically decrease වෙනවා after second quarter එකෙන් පස්සේ normal එක යනවා. මේකෙ පෙන්නන්නේ real export to GDP. GDP එකට ඇති වෙන shock එකක්. positive shock එකක් ඇති වුණොත් ඒ කියන්නේ export එක වැඩි වෙනවා මුලදී first 2 quarters වලදී. ඊට පස්සේ after you know that fourth quarter එකෙන් පස්සේ ඒක නිකන් ඒ shock එකේ effect එක නැහැ. ඒ sudden impact එකක් විතරයි තියෙන්නේ. that's true නේ. shock එකක ඒ කියන්නේ මොනවා හරි unexpected එකක අපි කොහොමද bond හරි වගේ තියෙන issue එකක monetary policy එක effect එකක් පොඩි කාලයක් නේ තියෙන්නේ. ඊට පස්සේ ආය normal level එකේ යනවා. මේ හැම එකම එහෙම තමයි තියෙන්නේ. මේක තමයි අපි explain කරන්නේ මේ වා model එක. ඒ කියන්නේ innovation කියලා කියන්නේ shock එක. Right, so then I have uploaded here to the assignment. This assignment is based on the your project in accounting subject. So then same data set you can analyze by using the econometric uh, analysis what we have discussed so far. So then deadline is 20th February. If you have that any question, it is time to discuss now. Right, please discuss so they know that email or if any issues. They are online and they are not working. They are online and they are not working. Right, but have you have any one other right, so then if any issue, so then please let me know. It doesn't matter whether that it is regarding the assignment or the topic what we have discussed. So then you want any revisions. Yeah,